start recording. The simplifying should be very straightforward for us. Let's talk about a couple vocab terms. If I have a square root, that's a radical symbol, or the cube root, fourth root. And inside the radical, it's known as the radicand, so under it. Okay? And so we're going to talk about, very straightforward. Guys, what's the square root of 25? 5. And I don't want you to try to confuse it with thinking, well, it's plus or minus 5. No, that's this, so don't write this. That's this. I showed you this last time. Actually, I don't know if we got to it because the screen wasn't working. We take the square root of both sides, so we'd have x equals plus or minus 5, right? Because isn't 5 squared 25 and negative 5 squared? But that's not solving. I'm simply asking, what is the square root of 25? And the answer is 5. So in this one, what is negative square root of 144? Well, first of all, let me ask you the question. What's the square root of 144?
12.
And then I just say negative 12. So you're like, oh my gosh, this is great. Good. Good. Okay. The first number 3 I have here. What's the square root of 9?
3.
And what's the square root of x to the 4th?
2.
X squared. Come down here, the second one. What's the square root of 81?
9.
And what's the square root of x to the 6th? X cubed. Because isn't x cubed times x cubed x to the 6th? All right, so we think we got to remember we add exponents when we multiply. Okay? And we're not afraid of we're not afraid of fractions. So the square root of 16 is
4.
square root of 49 is,
7.
and with the negative in front, we'll simply say negative 4 sevenths. You're like, oh my goodness, this is great. Hey, look at this one. Isn't the square root of something being squared the complete opposites of each other? So they cancel each other out, and we simply would have x minus 5 as our answer. Okay? So now let's look at cube roots. Something raised to the 3rd power is cubed, and then the opposite of that would be the cube root. What's the cube root of 1? 1. Because isn't 1 times 1 times 1? 1. Okay. Okay, now I have the cube root of negative 27. Okay, now we got to be careful here. Is that okay we have a negative underneath the cube root? Yeah, because a negative times a negative times a negative is negative. So what's the cube root of negative 27, Mitul?
1 over 3.
The cube root of negative 27 is the same thing as negative 27 raised to the 1 over 3. But what's that answer? What times itself 3 times gives me negative 27? Let him correct himself.
Plus or minus 3.
Did you say 1 over 3 the first time? Okay, so not that. And why are you saying plus or minus 3?
Because it's negative and you can't multiply anything twice to get.
You're right, it's 3 times. Somebody help him out. Thomas? Negative 3. Isn't negative 3 times negative 3 times negative 3 negative 27? Okay? Okay, you got to redeem yourself now, Mitul. Ready? Cube root of 8.
It's over 5.
2, okay, he's all over it. 2 over 5. Good. 2 over 5. Good. The cube root of x to the 15th. Mr. Hodges?
X to the 5th.
X to the 5th? That's right, because isn't x to the 5th times x to the 5th times x to the 5th x to the 15th? And the nice, easiest way is we can think, and we will get to this, we think of that as x raised to the 15 thirds, which is x to the 5th. This is written like this. If we want to, this is radical notation. This is rational notation. Okay, nth root. Nth root. Fourth root of 81.
3.
3. Because isn't 3 times 3 9? And another 3 times 3 would be 9. And 9 times 9 is 81. Okay. Fifth root of negative 32. Let's just do that first. But what would that be? Kyle? So I'm recording right now. So no.
2.
Okay, so 2 times 2 times 2 times 2 times 2 is negative 32.
Yes. No. 4. No.
He's totally not even kidding. Somebody help him out. Somebody help him out. Kaylee?
It's negative 2.
It's negative 2. Because, you know, Kyle, that was Kyle Williams. So that's like, this could be forever. Like, there could be students 2 years from now watching this video going, my goodness, Kyle. Negative 2. Okay? So you got to redeem yourself now, buddy. What's the fifth root of x to the 15th?
X to the 3rd.
Nice, and keep it going.
And X to Y to the 2nd.
Y squared.
Yeah.
Y'all good? Okay. We are not going to talk about this one today, so we'll just skip it. We'll save it. And go back a little bit. Moxie, what would be negative square root of 121?
That is a good question.
What's square root of 120? What's square root? You don't know what square root of 121 is?
Oh, it's 11, isn't it?
Yeah, so what's your answer?
Negative 11.
Negative 11. Okay. I just had to put some pressure on you. Right, we got it. We know them up to what? Probably 15 very confidently. 11 squared is 121. 12 squared is 144. 13 squared is 169. 14 squared 196. 15 squared 225. Okay, good. Okay, now here's the meat and potatoes of today's lesson. Graphing square roots and cube roots. Because I know how much you guys appreciate and like graphing. So let's talk about graphing the square root of x. Got a question. What cannot be underneath a radical? A square root, an even root. A what value? What cannot be underneath the square root? A what kind of value? Say it louder.
A negative.
A negative. You can't have a negative underneath the square root. So our smallest value of x we could have is 0. What square root is 0, guys? 0. So the output of that one is 0. Y'all need to make a little XY chart. What's the next square root that you know? Let's go with 1. What's square root of 1?
1.
Oh, nice. What's the next square root that you know?
2.
Really? What's square root of 2, Kyle?
Yeah. Oh, square root. No, I don't know.
I don't know either. It's 1 point something. It's irrational. But you know the square root of 3 is what?
I don't know that on here.
Oh, but do you know the square root of 4?
2.
So the next one we're going to put in is 4. And what's square root of 4? 2. Okay? Guilfoy, what's the next square root that we know? Nice. Think about it. We're counting in square roots. Square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is what, guys? 3. So you see how I went from here? Look up on the screen. I went 1, 4, 9. All right, let's graph it. Let's look at it. So we're going to plot the point 0, 0, 1, comma 1, 4, comma 2, 9, comma 3. We're going to draw our square root function. And then you're going to tell me the domain. Amanda, what's the domain? In interval notation, inclusively, what's my first x value? 2. You're right, 0, 2. 0, comma, infinity. Did you think I meant 2? Okay, no. And our range is the first y value, which would be what, John? 2. There you go. Okay, look up here on the screen. There's your starting domain. There's your starting range. For one that goes up to the right, let's keep it going. Now, we're going to have some fun. Things get shifted. How has this square root been shifted from the original square root of x? The x plus 2 underneath the radical shifts it how? Somebody raise their hand and tell me. Yes, Kyle. Kyle Williams again raised his hand, so here we go.
It's
You raised?
It's to the right or left.
Good. It is a horizontal shift, so you're right.
And I think it's towards the left.
Good. Left 2. John? What? You're going to go left 2, right 3? So this is the horizontal shift. We do opposite sign. Left 2. This is the vertical shift. Down 3. Same for the vertical. Left 2, down 3. Let's go to our XY chart. So instead of starting at 0, 0, we're starting at -2, -3. Now, what I want you to do then is I want you to find, so look at it. If I plugged in -2, that would give me 0. And 0 times 2 is 0, and 0 minus 3 is -3. Now I want you to do this for me. I want you to count in perfect squares, which is 1, 4, 9. So what's -2 plus 1? -1. Back up to the top. What's -2 plus 4? 2. What's -2 plus 9? 7. These, well, look, let's plug in 7. Everybody follow my cursor. Here you go. What's 7 plus 2? 9. What's the square root of 9? 3. What's 3 times 2? What's 6 minus 3? Now, look at this. Ready? Don't fill in anything else yet. Follow me up here. See this number in front? That's showing how my y value is increasing. Watch. -3 plus 2. Watch. -1 plus 2. Watch. 1 plus 2. 3. Let's graph it. Let's graph it. I recommend you start with the vertex, which is at -2, -3. And then we had -1, -1. And then we had 2, 1. And then we had 7, 3. I draw my graph, and that has a curve, and it should look like that. Does yours look like mine? What's the domain? What's the domain? Maya, what's the domain?
-3.
What's your first x value?
-2.
Yeah, inclusively. It includes -2 to infinity, right?
Yes.
Okay. Kaylee, what's my range? Thank you. Nice. We okay? All right. Now what? I'm going to hit pause. There's no horizontal shift. Nothing's changed underneath the radical. So our XY chart is going to start at 0, -4. And then, guys, you're going to count in perfect squares. 1, 4, 9. So 1, 4, 9. And then look up here. I'm not even going to waste my time plugging in. What's the number in front of the square root? -1. That means I'm going down increments of -1. So -5, -6, -7. Mr. Dice, I can't accept it. I got to plug at least one in. Okay, let's do it. Look up here. What's square root of 9? 3. What's negative? Then you make it -3 minus 4, which is what? Okay, let's plot these points. 0, -4. 1 comma negative 5. Oh, the negative has it reflected, and now it's opening down, isn't it? Oh, it makes sense, doesn't it? All that ties together. Now it's doing this. Oh, my goodness. My domain is inclusively 0 to infinity. The range is not consistent with what we've just been doing. Answer it properly. Yes. Go.
So negative infinity to inclusively negative 4.
Perfect. Nice. Nice, Allison. Nice. Questions? Okay. So now I'm hitting pause again. Negative 1/2, right? Okay. Oh my goodness, I might have to plot a half. How are we going to do this? 2 comma 1, 3 comma a half, 6 comma 0, 11 comma negative half. Now, if you need help, look up here. Your curvature better be still opening down. Nice. Nice. You can sit down when you're done. Why do you guys waste your time making all these points that you're not going to use? Your farthest you're going down is negative a half, and you guys just went down, made marks all the way to negative 10. Good. Let's feel good about cube roots. Okay. Now, we've already talked about, everybody make an XY chart. We already talked about that it's okay to have a negative underneath a cube root. Yes? I want everybody to put 0 in the middle of your XY chart. What's the cube root of 0? 0. Okay? Look up on the screen. What's the cube root of 1? 1. What's the next cube root? Miss Hayden? The cube root of 12, Miss Hayden knows is?
4. No,
Really?
10. Nope, wait, maybe I'm wrong.
Oh, she's crashing and burning, ladies and gentlemen. Her face is starting to get a little red.
Nope, nothing wrong.
What cube do you know after 1?
Oh, 8.
Ah, that a girl. The cube root of 8 is what, guys? 2. Oh, we're awesome. You guys are so smart. I know your other teachers talk bad about you, but I like you. What's the cube root of negative 1? Negative 1. And what's the cube root of negative 8? Your chart needs to look like that. And I don't want it to be the opposite direction. We write numbers we go from left to right. So look, that goes from left to right. Everybody clear on that? So when you're the ding-dong that writes it the opposite way and you lose points, don't blame me. Okay? Let's plot it. Let's look at it. This is how I recommend you do it. Look up on the screen. Start with the 0, 0 and work to the right. 1, 1, 8, 2. I would start that way and think you have the curvature. It looks like this. And then what happens is, you don't know this yet, that's called a point of inflection. You then are going to go negative 1, negative 1, negative 8, negative 2, and it's like a snake. It changes its curve. And then it starts doing that. So see how it's like the square root and then the opposite reflected. And the nice thing about cube roots, the domain and the range are both always negative infinity to positive infinity. So I'm just going to write it once big to be sufficient for both of them. Did you put from 8 to negative 8. What's the next cube root that you know? We'll go this way. What's the next one? What's 3 cubed? Nothing?
Oh.
What's 3 times 3 times 3? No pressure.
27.
Yeah. And then 4 cubed. What's that? 64? So it keeps on going. 5 cubed, 125. So it's from negative infinity to infinity. Cool? Okay, let's start shifting them. Okay, let's have fun. Here we go. You're okay though, right? You're not gonna need to scan that and think I'm bullying you or anything like that. Remember, I'm allowed to bully you mathematically. Okay? All right. Now, how has it been shifted, Michael?
To the left.
Left 2.
Down.
Put that in the middle. Negative 2, negative 3. You put that in the middle, just like we put the 0, 0 in the middle. And then, look up on the screen, negative 2 plus 1. Negative 1. Look up on the screen. Negative 2 plus 8. 6. Negative 2 minus 1. Negative 3. Negative 2 minus 8. Negative 10. Now, ready? I don't even have to plug them in. What's the number in front? So they're going up increments of 1. So this would be negative 2, negative 1. And then going the other way would be going backwards the other way because they're continuing to show that pattern of going up 1. Mr. Dice, I can't do that. I got to plug 1 in. Okay, let's plug negative 10 in. I would check it. I would verify it if I was taking a quiz or test. What's negative 10 plus 2? Negative 8. The cube root of negative 8 is negative 2 minus 3. Bingo, negative 5. Okay, and then I recommend you start with your vertex in the middle and graph negative 2, comma, negative 3. And then make your snake to the right. Negative 1, negative 2. 6, comma, negative 1. And then we have this happening. That's loud. And then go the other way. Negative 3, negative 4, negative 10, negative 5. And see how the curvature changes? And you guys are all over the domain and range. It's what again? Negative infinity to positive infinity. You guys are so smart. Those are all perfect tests back there, right? Just put minus 0 on top of all of them, call it a day?
Yes.
Sure. Tony, why would you say
Because he's got a minus 0. He's going to show that he dominated and he wants to see you guys not. How much time we have? Well, we got time. Sophomores, get to the board. Oh, it's going down increments of 1, isn't it? Because there's a negative in front. You guys are doing awesome. And now this time, our snake has been flipped due to the negative. It's going down as we go to the right. It's going up as we go to the left. And the domain and range, though, don't change. And flash the homework assignment up on the screen.